Composites One is the leading composite materials distributor in North America. We have excellent technical teams, a dedicated advanced composite team, and aerospace teams. We're joined in the Closed Mold Alliance by Aerovac, an innovative and dependable process material supplier. So what we're doing here today is we're laying up a representative section of a wind turbine blade.
What we're using here today is our all-glass structural flow media. We refer to as G-Flow 500L. You can see it's a really open weave pattern. Looks like a window screen or a scrim. The reality is all of the zero direction fibers are underneath all of the 90-degree fibers. So you're building in two direct flow channels. The black tracer yarn you can see on the fabric here is indicating that zero direction, or your, in this case, your preferred direction of flow. You can see on the layup we've got here that Keith's building right now, we've got the direction of flow built across the narrow part of the panel, because that's the way we've designed the laminate.
So we'll go ahead and put the rest of the core material in our wind blade section, and then we're going to cover the laminate. So one of the things you see them doing is they're using a little bit of roving to fill up any gaps we might have, so that the fibers can conform, and we're not going to get any resin-rich areas or any voids. Now they put the inner skin of the biax E-glass reinforcement in. They're using some spray tack adhesive to hold everything in place until we get the vacuum bag on, which is going to give us our consolidation pressure. We just want to use a light mist of the spray adhesive just to hold stuff in place.
Next up, we have Infuply, and it's going on here. So Infuply is what we call a combination product. It's actually two different materials that we manufacture together. So we've got the blue that you see is the flow media to promote the flow of the resin and the removal of the air. And combined with it in one product, we have a perforated release film, which is the pink material that you see there on the underside, just to improve how quickly you can do a layup.
So this is our feed line. It's actually spiral cut tubing wrapped in a peel ply. And then on the other side, we have our vacuum line. We're going to put on the 400Y bagging film from Aerovac. We have a small roll here for our demonstration. But one of the things we're going to do is we're going to tack the corners down so that we want to use basically all of the bag in the part. Everything that's outside the sealant tape really isn't going to do anything for us. It's just going to give us trouble when we're trying to seal the bag. Okay, now we have the bag sealed, and we're ready to connect the vacuum. So what Russell is doing, we have a vacuum hose that runs to our catch pod over here. We'll do a drop-down test once we get vacuum on the part, make sure we don't have any leaks in the bag. So one of the things with the infusion process is since all our reinforcements are loaded dry, all our core material and our process materials, we have plenty of setup time. We're not fighting a resin gel time. So we can make sure that everything's positioned correctly and that the bag is pulled down before we actually mix the resin and start the resin flow. So now we have everything connected. We have our resin feed line connected. It's just clamped off for a minute. So are we recirculating? Or? Okay. So we're starting the machine to recirculate the resin. So it'll draw the resin through the machine and then back into the bucket. While we're doing that, we'll do a quick drop test on our part. I think we're ready to inject. Drew, you ready? So now we can see the resin flowing from the innovator. It's going to fill up our spiral wrap tubing, and then it's going to flow across the Infuply, and the laminate's going to saturate down through the thickness. That G-flow in there is going to help give us more permeability in the laminate, make sure we get everything wet out. And then we have the resin brake on the other end connected to our vacuum source. So you can see our spiral wrap is filled completely now. Now we're starting to get flow across the surface.
So one thing, your observations doesn't end since you started the resin. You want to watch what's going on, right? The part will tell you if there's a problem. So let's say, for example, the resin front over here is far ahead of the resin front over there. That would cause two things that we're looking at. Either we have an issue, like maybe the bag got tucked underneath our feed line and is cutting off our flow, or maybe there's a leak somewhere. So you'll continuously look at the process, and the process will tell you what's going on.
Other areas to check, you notice we chamfered all the materials. We want to make sure the bag and the peel ply and the Infuply is all tucked in the corners so we can get resin race tracking. You can see a little bit of it here on the edge. That's not going to give us a problem for this particular part, but it's just something to be aware of, as Russell pointed out. But you can see it's a pretty controlled flow. We have a little bit of resin coming back here, but it's going to continue to fill in because we have a good connection to our vacuum source. And that's basically the infusion process in wind energy. Good morning. Welcome back to the demo zone presented by Composites One and the Closed Mold Alliance. You just saw our wind energy infusion demonstration. Now we're going to look at the part we made and do some repairs on that with 3M. So I would like to introduce Will Barrett, Joe Eaton, and Tom Henry from 3M.
Thank you. The demonstration we're doing today is a wind blade repair, and we're going to start with a 320 grit new innovative extract sanding disc. This has been in the market for about 60 days. It is revolutionary with 97% dust extraction and cuts faster with the precision shaped grain. This demonstration, Joe, have at it.
Okay, so as you can see, it sucks up a lot of the dust. As Will said, 97% of the dust. This is our new Wind Protection Tape 2.1. It's a polyurethane-based film with an acrylic adhesive, very tough, very strong, and it's meant to protect the leading edge of wind turbine blades from the effects of rain erosion. Rain will impact fiberglass and create pitting, so this is meant to spread the raindrop force out to keep it from hurting the fiberglass. So we just sanded the blade. Now we want to clean it off, right? As the demo showed. The other important thing here is if you applied a polyurethane filler or top coat, you want to make sure those are completely cured. So, we're doing a small section of tape. The first thing you want to do is get your adhesive liner started. And you can see it's very tacky. So as soon as you expose that adhesive, you want to wet that down so you can handle it. And again, you want to spray all surfaces, the substrate, the top of the film, and the adhesive. So as you can see, this allows us to align the tape and get it ready so it's centered on top of the leading edge. So we have our squeegee. You want to work from the middle to the sides, right? And don't be afraid to use lots of solution. So Tom, if you want to grab that. Most people work maybe 2 or 3 feet at a time, so it's manageable. And then you just work yourself down the leading edge of that blade. It's a 2-man job, and again, lots of solution. All 3 surfaces is key. And then we'll finish that, yep. Again, don't be afraid to use a lot of solution. It really helps, as you can see. Now we're building adhesion, so this will build adhesion fairly quickly. So you want to make sure you're getting all the bubbles out. And then we can go back and just dry it off. Right? And that's basically done. As the video shows, we would apply this edge sealer now to the edges of the tape to protect from moisture, and also it's an aerodynamic reduction. So that's the process.